To classify this quadrilateral, I want to look at the information that's given me in the diagram, and I can see that the only thing that they're really showing me as far as properties go is they're showing me that I have 4 congruent sides. And so looking at my properties chart, I can see that 2 quadrilaterals have that property. The 2 possibilities are either that this is a rhombus, that's got 4 congruent sides, or a square that also has 4 congruent sides. So I have 2 names that I could give this. So I want to look for a way to either prove it's a square by knowing some more information, or eliminate that and default to the name of rhombus, because rhombus is a less specific name. So looking at this figure, I can see that the name I can eliminate is going to be a square, because I can see that my angles are not right angles. I wouldn't be able to assume they are right. Like if it looked like a square, I couldn't go by looks. But I can see that for sure those angles are not right angles, and so I'm going to give this shape the name of rhombus. And so now that I know this is a rhombus, I can use all those properties I have checked off in order to answer these questions. So let's go ahead and get our figure labeled, and let's go ahead and answer this. So they've told me segment LM is 5, so I'm going to label that in my diagram. They've also told me the measure of angle QLM, so trace that out if you need help finding it. So trace from Q to L to M. That angle is going to be 30 degrees, so I have a little 30 degrees right there in my diagram. So let's go through and answer some of these questions then about this rhombus. The first thing they ask me is to find the measure of angle LQM. So again, trace that out so we can see where we're looking. I'm going to draw my diagram to help me see it. So angle L to Q to M. And so basically I want to know how these diagonals intersect. And if I look at my properties of a rhombus, one of my properties are that diagonals are perpendicular to each other, meaning the angles in the center of this figure are all going to be 90-degree angles. And I may want to write down the reason I know this, and I'm going to say it's 90 because, like I just said, our property was that diagonals are perpendicular to each other, meaning all those angles in the center are right angles. So I'll add a little right angle symbol in there. Next up, they asked for angle LMQ, so let's trace that. I'm going to switch colors so we can see a little bit better. So trace from L to M to Q, and I see that I'm looking at that other angle. What I'll do at this point is I'm going to just look at this entire right triangle. Using some old information, so nothing even to do with a rhombus, I know that the angles in a triangle have to add up to 180 degrees. So if I take 180 and subtract off the 90 from the center angle and the 30 that was given to me, the angle left over must be 60 degrees. So I've got a 60-degree angle in that spot in my rhombus, using the old information I know about triangles. Next up, they ask about angle PQN. So again, let's switch colors one more time and trace that angle out. So angle PQN is this angle down here. And again, I know that it's going to be a 90-degree angle because diagonals are perpendicular to each other, so all those angles are going to be right angles in the center. I suppose I could have also used vertical angles. Angles that are across from each other are equal, so you know that that's going to be 90. And finally, they asked me for a segment length, and that's segment MN, so this piece on the side. Well, because we identified this shape as a rhombus, and I knew that all 4 sides are congruent, I know that all sides are going to be the same length. So if one side is 5, they are all going to be 5. And you may want to just write down the reason you know that. I'll say because all sides are congruent in a rhombus. Oops. Sides are congruent in a rhombus. Let's work with one more rhombus problem before we wrap this up. This time they've given me both lengths of the diagonal of a rhombus. One diagonal is 12 inches, one is 16 inches, and they asked me to find the side of the rhombus. Well, the first thing I would do is I would probably draw a picture so I can get a good visual for what's going on. So let's draw just any old rhombus we want. We know that all 4 sides are the same length, so I'll add those tick marks right away. And then let's draw in our 2 diagonals. So one like that, and one like that. I can see that one diagonal is longer than the other, so I'll label that diagonal 16, and I'll label the shorter diagonal 12. And so what I want to do is find the missing side of this rhombus, and once I find one side, I should know all the sides. To do that, I'm going to have to use one property of a rhombus. I'm going to have to use the fact that diagonals are perpendicular to each other, meaning diagonals intersect at right angles. So I'm going to put a little right angle symbol right there. And actually, you know what, there's one more property I'm going to need to use, because what I'm going to do is I'm going to be working with right triangles. So let's just kind of highlight this one right triangle. I'm trying to find that side. And so I suppose since I'm working with right triangles, Pythagorean theorem would be a great thing to use at this point. But what I need to do is find out what the sides of that triangle are, and they're not 12 and 16. That was the entire length of the diagonals. But another property of diagonals are that diagonals bisect each other, meaning they cut each other into two equal pieces. So my longer diagonal is split into 8 and 8. And my shorter diagonal is split into 6 and 6. And so what I want to do is just look at that one right triangle at the top, and I want to just work with this using Pythagorean theorem. So let me kind of redraw that over here. So there's my right angle. The shorter side was 6, the longer side was 8, the longer leg was 8, and then the hypotenuse, or the side of the rhombus, is going to be the side I'm trying to find x. So this is really just a Pythagorean theorem question. So let's set up 6 squared plus 8 squared, and put that equal to x squared. And you may remember this one is a triple, a 6, 8, 10 right triangle. But if you didn't remember that, we can go through and solve this real quick. And once I take the square root of both sides, I do see that that missing side is going to be x, or that is going to be 10, sorry. So 10 inches is going to be the side of this rhombus. They did ask me one more question. They asked me to find its perimeter, which is the distance around the rhombus. Well, since we do have a rhombus, all the sides are the same length, so I'll label all 4 sides 10. And then to find the perimeter, it's simply a matter of adding up 10 4 times, or just doing 4 times 10 because they're all the same length. And I get a perimeter of 40 inches for this rhombus.